Okay, we're told that this is a geometric sequence. Here are the terms in the sequence: 5, -1, 1/5, -1/25, ... This is an infinite sequence. It goes on and on forever. They just gave us the first few terms. Now they asked us to find a formula for the nth term. We call that formula a sub n. And they told us do not use a recursion formula. What that means is do not write a sub n equals something that involves a previous term, like a sub n minus 1 or a sub n minus 2. No, we don't want it to depend on any a sub anything. We want a sub n to equal something that only contains some numbers and the value n, the index n. Okay, to do this, let's see. The first thing we're going to do is we're going to use the fact that it's geometric. They told us it was geometric. So we may use the formula for finding the nth term of any geometric sequence. A sub n equals a sub 1, the first term, times the common ratio r raised to the n minus 1 power. So step 1 for using this formula is to find the common ratio. Then we'll have an r value to plug into the formula. Well, you know, r is acquired by taking any term a sub n and dividing by the term that came before it, a sub n minus 1. So let's take the term -1 and divide it by the term that came before it. -1 divided by 5 equals -1/5. So we have our common ratio r equals -1/5. Now I want you to notice that the fact is we were told that this was a geometric sequence. We didn't have to prove it. We were told that it's geometric. That means that it has a common ratio. Every ratio between successive terms will be the same number. So we may choose to use any two consecutive terms to find our common ratio. We just happen to choose the easiest, -1 divided by 5. That was the easiest one to use. But the point is, since we were already told it was geometric, we could have chosen any two consecutive terms, taken the second one, divided by the one before it. Okay, so r is equal to -1/5. Now we need to find the first term, a sub 1. Then we'll plug that value into the formula in the cloud for a sub n. Okay, a sub 1 is just the first term. So look at the list they gave us. A sub 1 is equal to 5. That's the first term on the list. Okay, we have everything we need to use the formula for the nth term. So step 3, apply the formula. A sub n equals a sub 1, the first term, times the common ratio r raised to the n minus 1 power. So in this case, we have, plugging our values in, a sub n equals the first term, 5, times the common ratio, -1/5, in parentheses, raised to the n minus 1 power. That's our formula for the nth term. Now, I would like you to try this and see if you can get an answer. So you try, given the geometric sequence 3, 9, 27, and 81, find a sub n. All right, it's a geometric sequence, not a series. A series means we'd be adding it together. This is a sequence. Do not use a recursion formula. Same instructions we had. So I want you to put this on pause and figure out the answer by going through step 1, 2, and 3, and then come back, press play, and let's see if you get the same result that I get. For the first step, we get the common ratio. R equals 9 divided by 3 equals 3. Second step, the first term, a sub 1, is equal to 3. And the third step, use the formula. A sub n equals the first term, 3, times the common ratio, 3, raised to the n minus 1 power. Now we can go ahead and simplify it because we're multiplying 3 to the first power times 3 to another power. So that's a single base 3 raised to the sum of the two powers. So it's 1 plus n minus 1. The ones cancel and we get the nth term, a sub n, is equal to 3 to only the nth power. Ta-da! Hope you got it.